Welcome to Engineering Success Profile Editions. In this episode, we're going to hear from Nicola Grahamslaw about her role as a systems engineer at the SS Great Britain Museum. Hi, Nicola. Welcome to the show.
Hi, thank you for having me.
Hi, great to have you. Can we start right at the beginning? Why did you choose a career in engineering?
I guess I kind of didn't really choose a career in engineering from the beginning. Right. So I was always interested in science, and I was quite good at maths at school, but I was much more interested in kind of business and economics. And I did A-level economics, and I absolutely loved it. I really liked it. But I think my teachers didn't want me to turn my back on science. My teachers were quite keen for me to carry on with science. And so I ended up doing, my head of sixth form suggested that I have a go at the engineering education scheme. So that's something which I think it still runs now. Right, okay. And how that works is that there's you kind of pair up schools with companies, and you get together a team of a few students, and the company kind of sets you a real life engineering problem. And then you kind of meet once a week after school, and you kind of do some research on it, and then there's also like a residential course at a university, and that was the reason I signed up for it, because that bit sounded really fun. And to be honest, the project, I'm not even going to talk about the project that we did because it was really boring, but when we were at the residential course, we got to meet lots of other teams who were working on other projects of varying amounts of interestingness. One evening, we all got together and they'd put on some talks for us about kind of various different applications of engineering. And the only one I remember, because I remember being really fascinated by it at the time, was about Concorde. Now, a lot of people get quite nostalgic about Concorde. People a bit older than me. But this particular talk was not about how amazing an achievement Concorde was. It was about a big accident that had happened in 2000. And it was about how engineers managed to piece together all of the various bits of evidence that they could find after the accident. And how they used each of those things that they found to kind of work back and figure out exactly what had happened and what had caused that. And then they could use all of that information to then obviously make safety improvements and stuff. And at the time, I was quite interested in more kind of humanities type subjects. I had thought about maybe trying to become a barrister, and it was this process of kind of collecting up all the evidence and then kind of doing a bit of maths and doing a bit of science and using that to piece together the story of what happened. And that was when I first thought, oh, okay, yeah, that could be, that sounds a bit more interesting than fixing engines, which is, I think, and I know it's a really a bad stereotype, but like that is genuinely up to that point what I had thought engineering was about, you know. And I think we've got this problem in the English language with the word engineering and the word engine, and I might come back to that later. But so that was when I first kind of developed any interest at all. And then I think that combined with my teachers imparting some words of wisdom, which was that actually you go to university, do a degree in engineering, you don't have to become an engineer. And actually engineering degrees and STEM degrees are really in demand for management consultancy and finance and business. And I didn't really know actually what any of those things were, but I knew that I was interested in all that sort of thing. So I thought, okay, well, I'll go and study engineering. And I chose a course which had as many disciplines of engineering as possible in the first year and the second year, which made it really, really hard work, but also meant that by the time I actually had to choose a specialism, it had given me a chance to know a bit more about it, because I hadn't had chance to learn that before uni. And then again, my head of sixth form, I owe a lot of my success to him. My head of sixth form had said to me, oh, you know, you're a girl, you've got an offer to do engineering at a good uni. I had an offer to go to Cambridge. You should have a look around and see, there'll be people out there who will probably sponsor you. You can get scholarships, you can get that sort of thing. You know, have a look online and see what you can find. And so I literally went home and searched, like, you know, engineering scholarship, and then wrote my town into the search engine. And one of the first options that came up was this engineering consultancy company, who had an office just around the corner from my dad's house. And so I applied to them for a scholarship.
Yeah.
I didn't really know very much about them or what they did. I just knew that they were going to give me £1,500 a year, which sounded great. I also got some work experience with them in the summer, and I think that really was what sold it to me, because they were a small consultancy. They were quite young. They actually sent me, for my work experience, they sent me not to their small town office, they sent me to their Bristol office. So I lived in Bristol halls of residence in the summer holidays, with a couple of other interns, and we had a great time. So it was a really nice way to spend a summer. They were quite a young company. They were really sociable. There was lots of drinks after work on a Friday, that sort of thing. And so when the time came to graduate, all of the financial management consultancy companies, etc., were all coming and headhunting engineering graduates, and I just thought, actually, no, I'm going to go and work with my mates in Bristol. So that was it, really. And and I just thought, I never really had my whole career planned out. I just thought, actually at the time I graduated into the recession as well. I started work in 2009, and I just thought, well, I've got this job lined up, that's a really good one, so I'm going to do that for a while, and then we'll see. So I guess I never really had a long-term plan to become an engineer. I just had a go and liked it for various different reasons, and thought, well, I'll carry on doing it until I stop enjoying it. Which is exactly what I did.
So you're a systems engineer. What skills do you think are needed to be, a good systems engineer?
So the really exciting thing about the consultancy that I worked for, because it was it's a much bigger company now, but when I first joined it was quite a small company. And the way that they structured themselves was by discipline rather than by market sector. So rather than having like an energy team and an aerospace team and a defense team, they would have a fluid mechanics team and a structures team and a materials team. So you would go into your discipline, and I started out in fluid dynamics, but you would actually apply those principles to lots of different engineering areas, and I found that really interesting, like this idea of taking a concept from one engineering area and applying that same concept to a totally different engineering area, and then kind of as I kind of developed a bit more in the skills, and got a bit more confidence, I then got seconded to a team who were working on a power station, and it doesn't sound like a very exciting project, but it was a really interesting project because, and I'm going to go back to the Concord lecture now, it was about a temperature sensor that was giving a confusing result. And this thing was like buried right deep in the middle of a nuclear reactor, so you couldn't just take it apart and have a look at it. So this temperature sensor was giving a confusing result, and what the team had to do was to find whatever other information they could and piece together whatever other evidence they could to try and figure out what was going on. So what was causing this unusual result, and more to the point, was it safe to keep operating? And how could we prove it was safe to keep operating? And did we need to do anything? Did we need to make any modifications? Did we need to run it slightly differently? And at that point, although I started off with the fluid mechanics side of it, because it was all about gas flowing past the sensor and how that would affect the temperatures, so the heat transfer. At that point, I then started working a bit more in a way that required you to see the bigger picture. So it wasn't just about this one temperature sensor, really, was it? There was all sorts of things that could be causing this problem. And at that point, I started to really gain an appreciation for just how much there is that all has to come together for something like this to work. So if you think about a plane, for example, you might be able to explain to somebody how airflow over an aerofoil generates lift. But actually the mental leap between an aerofoil generating lift and an A380 leaving the ground, like, to me, that's phenomenal. Like, so many different things all have to come together. And that's the bit I find really blows my mind. And so once I started working on these projects where you started thinking about the bigger picture, that was when I sort of realised, actually, yeah, this is what I'm interested in.
Yeah.
I am interested in the nitty-gritty details, but I'm much more interested in the bigger picture. And that's what a systems engineer specialises in, kind of helping to make sure that all the individual different components all work together to make a thing that just works.
Yeah. So you work at the SS Great Britain at the moment. What does your role there entail?
So the SS Great Britain is, or was, or still is, was the world's first iron ship, and she was designed by Isambard Kingdom Brunel. So she's got a few claims to fame. In fact, that's probably leaving out the main one. Her main claim to fame is that she was the first ship to have a propeller rather than having paddle wheels on the side. Although the propeller is less relevant to me because it doesn't exist anymore. It got broken up pretty early on in her life. So, but the iron hull of the ship still exists today. So the ship sailed over 1 million miles, we think, or in fact we know, we've got all of the ship's logs, and then got abandoned in the Falkland Islands. But was in 1970, so actually this month we're celebrating our 50th anniversary. She was salvaged and she was brought back to Bristol, opened up as a museum. But the combination of the very early kind of wrought iron, I mean, wrought iron itself wasn't early at that point, but rolling it out into plates on the scale that is required for a 100-metre long ship, that was very new. So the combination of this new processing technique and all of the impurities in the iron, combined with all of the time at sea, which you get salt into the metal, and those people who know a bit about marine engineering will know that iron and salt don't mix very well together. So that basically causes very rapid corrosion. And in the 90s, they realised that the ship wasn't going to survive, basically. So in order to stop the ship from corroding, they needed to create an environment around the ship which excluded either the oxygen or the moisture. So the team applied for a big grant from the lottery, and employed a big team of lots of different disciplines of engineering who all worked together to design this system, which basically involved putting a glass roof over the top of the dry dock, so at the level where the water would have been, and then underneath that and inside the ship, creating a ventilation system which circulates very, very dry air. So the idea is that this system stops the metal from rusting, and keeps the ship structurally sound. So that was all completed in the mid 2000s, and my job was not created until for another 15 years or so. But the purpose of my job is to basically, so before I was there, they had individual contractors who kind of came in and maintained each of the individual bits. But my job was to bring ownership of the whole system together, back kind of to the trust. So the SS Great Britain Trust of now have, via my role, technical ownership of the system as a whole. So it's not just, I mean, you can say, this sensor's not working, or, that fan needs replacing, that sort of thing. But it's not really about that. It's about how the whole system talks to all the components talk to each other. And is that still the best way to do it? Is that still the best way to solve the problem? So a lot of what I've been doing is about control algorithms. Some of it has been about instrumentation. But also some of it is about kind of fluid mechanics. So my job really, rather than to fix things that go wrong, is more about figuring out who we need, or what needs to be done, rather than actually doing it. And then also the other part of my job is about kind of long-term strategy. So is this the best way to look after the ship in the longer term? And in particular, can we do it for less energy? We're very, very conscious of sustainability, and it's quite an energy intensive process, keeping a 100-meter long ship at 20% relative humidity. It's not an easy thing to do. So does it need to be? Is that what needs to happen? Is there a lower energy way of doing it? So kind of asking all of those big questions for the future. and hopefully you can see that you need somebody who can do that kind of bigger picture type of thinking,
yes,
to be able to know what questions to ask.
Yeah. So, you know, your engineering journey's been pretty amazing so far. Do you think that highlights the interchangeable skills that engineers have?
Yeah, I think it does. I mean, one of the things, and I said right at the very beginning, one of the reasons I went into engineering is because I knew that the skills that engineers have are in demand in other places too. So I guess I always knew that, even if I was never, to start with, I was never really passionate about engineering. I wasn't one of those people who was just like, oh, I love taking things apart, or, I'm really fascinated by flight, or any of those things. I just thought, this seems like, I quite like science. And this just seems like a really sensible set of skills to develop, because they're versatile, they're transferable, and actually, like, whatever I decide I want to do in the future, the chances are I'll have some of those skills. And I do think that engineering is a really good profession to go into if you want to be in demand and if you want to have those versatile skills. Definitely.
Yeah. So do you think it's important as engineers that we routinely evolve ourselves and move ourselves forward?
Well, yeah, absolutely. I think that I know that there's a lot of stuff you see in the media about, the future, and you've got your flying cars and your AI and stuff. But if you think about like children at school now, what they're doing is they're trying to get an education that's going to train them to do a job that might not exist yet. And that's pretty, and like, when you think about it that way, that's pretty scary. You just think, oh, I've spent so many years and so much money as well on my training. What if by the time I graduate, this is all done by machines, or this is all done by robots? And so I think it's really important that you kind of step away from the specifics and look at not just the skills you're learning, but firstly, how you can apply the same skills to something new. So, I mean, my job at the SS Great Britain didn't exist when I graduated. And there are lots of jobs. There are probably jobs I'll do in 10 years' time that don't exist now. And I think it's really important that you kind of bear that in mind, because you don't know, like, things are always changing. I mean, thinking about the situation we're in right now, nobody could have predicted how 2020 will have gone.
No.
And actually, I got asked by a teacher last week, what do you, with the world changing the way it is at the moment, what would you recommend? What career advice would you give? And the answer is the same. You have to look at the skills that you're learning and be confident that you're going to be able to apply those skills to a job that doesn't exist yet. So, and a lot of it as well is about learning how to learn as well. So it's not, and when you're learning how to use a software package, you're not really learning how to use that software package. You're learning how to teach yourself a software package.
That's right.
Because, in the future, the one that you've spent years learning, probably nobody will use that anymore.
That's right.
But the fact that you've gone through the process of teaching yourself how to use it means that you'll probably go through the process of teaching yourself the next one a bit more quickly. So those are really important skills, I think.
So for you, what's the most challenging part about being a systems engineer?
So for my job specifically, I am the only engineer at my organisation, which means that sometimes you have to. Sometimes it's harder to get a second opinion on something than it would have been in my previous jobs. Quite a lot of the time we would have kind of taken a problem and talked about it in a group and kind of thought, and a lot of the time, like, I won't go so far as to say that I'm on my own. I can always get a second opinion, but it's not the opinion of another engineer. So a lot of the time, if I want a second opinion on a problem, I have to find a way to describe it so that somebody who isn't an engineer will understand it. So it's a skill that I think a lot of engineers would benefit, even in traditional engineering, from. Because engineers love jargon, they love big words, and they love to sound clever as well. I think engineers get a kick out of sounding clever, but there's just something really grounding about sitting down with somebody who doesn't even have A-level maths maths and trying to explain to them this
yeah,
thing so that you can get their opinion on it. And I think that's been, I mean, it's been both a big challenge, but it's also been like a really big kind of, I feel like it's developed my communication skills a lot in a really good way.
So then what's the most rewarding part of being a systems engineer?
I think I sort of already described this. I'm just actually seeing all of the things come together to make the project is just incredible. Like the first time, the time with the power station, you know, to actually be able to see the news headline saying, you know, this station has now returned back to full generation, and to be able to look at that and say, I helped do that. You know, I think that's not really even specific to systems engineering. That's specific to all types of engineering. I think to see the finished product and just to think, I helped do that.
Is
the most rewarding part of the job.
So, you know, it's important that we attract more talent into the engineering industry. What message would you give young people to actually attract them to think about a career in engineering?
So I think I would say, firstly, that engineering is not necessarily what you might think it is. So I said right at the beginning about engineering and engines. So this is a really interesting little fact that English is one of the few languages where the word engineering and the word for engine actually sound anything like each other. And in the word engineering actually doesn't come from engine at all. It comes from the same Latin word as the word ingenuity, which is literally is about creativeness. And so, you know, creativeness, that's not a word, creativity, and finding a creative way to kind of get around a problem or to solve a problem. So engineering it isn't necessarily about planes and bridges and all those sorts of things. Like it can be about all sorts of things that you wouldn't possibly think. But also the other great thing about engineering is that the skills, and I've said this probably 5 times already, the skills are so versatile that you can always move. You can always find a different job using those skills. I mean, you might not be able to do it straight after graduation, but once you've built up a bit of experience, engineers are always in demand, so you know you're more likely to have your pick of the jobs rather than having to settle for whatever you can get. So you know, if you want to live in a particular place, for example, the chances are you'll be able to find a job. So it's the versatility, I think, is why I think more people should consider engineering. But I also think that there's a misconception about like who can be an engineer as well. Like you know, you don't have to be. So that's easy for me to say because I was academically very strong. Like you don't have to be the best at maths to be an engineer. It's actually much more important that we have teams of people who are good at maths, but also teams of people who are good at communicating, or who are good at organizing things, who are good at like planning, and there are lots of other skills which make a good engineer. It's not all about maths and science.
And finally, just a general question. You know, a lot of the students are not going to have the opportunity to speak to professionals such as yourself. What tips could you give them if they were going for an interview to make them stand out, obviously, in what's going to be a very crowded arena?
Okay, so when applying for any job, my tip would be to tailor your application as much as you possibly can to the job that you are applying for. So that would be my first tip. Like when you're reading covering letters, so I've recruited interns and things. When you're reading covering letters, you can tell who's copied and pasted the same one to everyone. And you know, you want to employ somebody who wants to work for you. It's better for everybody if that's the case. So you need to persuade the employer not just that you're the best person for the job, but also that you really want the job. Which sounds really obvious, but you know, so it's worth just trying to make sure that you're that you kind of know a bit about them, and also ask questions, you know, ask what the job would involve, ask what they like about working there. Because, you know, they want you to be happy as well, because that means they don't have to recruit somebody else when you quit if you're not happy, you know. So it's a two-way process. Generally, you know, if you are enthusiastic and you're really genuine, like, that will make you come across really well. The other piece of advice I would have is that to not be constrained by your academic stuff on your CV. I mean, whatever you've done outside of uni or outside of engineering work, you know, if you've helped out with the local scouts, or if you've been in an orchestra, or all those sorts of things, actually don't just write "I was in the orchestra." Like, think about what skills you developed from being in the orchestra, and those are just as important on your CV as the skills you've developed from your course, I think. So yeah, you need to bring those out.
Nicola, that's it. Thank you so much for your time and for being part of the profile editions.
Thank you for having me.